1,000 yen refunded for malfunction, still several times the list price. Paddle control for SEGA Mark III. The original list price was 1,200 yen, the one Bunsen bought was a bare unit with no box or manual. It did not work, so I got 1,000 yen refunded, but it was still expensive, still several times the list price, a premium controller. This one works normally. This one is defective. The working one. It moves left and right properly. Defective one. It does not move. It does not move. It will not move. This one is defective. This one works normally. Defective one. It makes some kind of sound when I turn the working paddle. No sound, smooth. When it reaches the end, it feels like this. Defective one. The sound is different. Something is wrong, the buttons are normal. Let's open it. 6 Phillips screws. First loosen them all lightly. If I use an electric driver right away, it puts stress on the plastic side. Electric driver. Now let's find out why it does not work. Huh. Look at this. The variable resistor for the paddle is spinning freely. Normally 3 wires are connected, they are all detached. This is supposed to be fixed in place. I think the nut has come off. Let's remove it. It comes off easily. Normally it is fixed here with a nut. This hole. The locating pin goes into the hole and holds it so it cannot move. The nut and flat washer came off. By fixing the nut, only the rotating shaft moves. The working one. Same movement as the working one, smooth. This is the cause, the nut loosened and came off completely. So the variable resistor was spinning freely, that cut the wires and made it stop working. There are all kinds of parts in here, it even has electrolytic capacitors. Hey! Hey hey! The wires going to the main unit. Number 8 has the core wire exposed. Number 9 is melted. As for the rest, this area bothers me a little, but the others are probably okay. Since I opened it anyway, I will replace the electrolytic capacitors later too. It is not rusted. This is different from a normal controller. This IC integrated circuit, SEGA 315-5243. The voltage changes with the paddle knob position, and it converts that into a digital signal the console can understand. A dedicated IC, this part marked X1, creates the timing to run this IC. It works like a metronome when playing music. So the IC does not run at random timing. It creates a steady rhythm. A normal controller only sends switch on and off signals. This converts the knob position into numbers internally, then sends them to the console. For 1,200 yen back then this was cheap. Let's also open the working one just in case. It is dirty, hand grime. I need to clean it later. So this is how it is connected. I would not call this clean, but for handmade work it is acceptable. All 3 wires are connected properly. I will tighten it just in case. It is not loose, but I lost my small wrench, so I will use a larger adjustable wrench and retighten the nut. This should be fine. The shaft has a D-cut cross-section, so it fits only in a set position. For now these parts, let's wash them. The inside of the paddle is dirty. Ultrasonic cleaner. Add holy water. Add just a little neutral detergent. Switch on. It got fairly clean. There is some detergent on it, so I will rinse it. Heat heat gun. This part will not come off unless I bleach it with hydrogen peroxide, but it got much cleaner. It got really clean. The working one with hand grime on it. It got this clean.
Mercury.
Dirty. Flux residue, number 8 and number 9, they were overheated so more flux came out than the others, that is why the insulation melted. This is not cigarette tar, it is rosin flux. IPA. Apply lubricant. Lift the dirt. IPA. Scrub, 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 scrub. Good, the contact resistance dropped. First the number 8 and 9 wires connected to the cable, they are melted so I will redo them. Soldering iron. Let's lower the temperature a bit. There is no path for heat to escape so it may melt. Solder sucker. It is really melted. I do not want it shorter, but it is melted. It got 2 millimeters shorter. Wire stripper. Because it is stranded wire, the melted insulation got inside and will not come off. Twist and twist. Twist and twist. Let's lower the temperature a bit more. Solder wire. Pre-tin the core wire. The brown one too. I have to do it quickly or it will melt. Good. Coat it with solder like this. IPA. Good, it did not melt. This is the cleanest of the 9 wires. Consumable parts: electrolytic capacitors. Electrolytic capacitor stock. I prepared them in advance. The ones installed here are 1 microfarad 50 volts, 10 microfarads 16 volts, 220 microfarads 10 volts. The capacitance must match. The rated voltage is okay if it is the same or higher. Lower is not okay. Let's install them. Raise the temperature, heat escapes through ground so I need a higher temperature. Add fresh solder to make removal easier. It fell off. The hole spacing is wide, so spread the legs a little. This one too. If you force it into narrow holes, the rubber seal loosens and it leaks more easily. Its life gets shorter. This one too. I widened all of them. Hold it down with the pad of my ring finger. Use less solder because it is not through hole. Replacement complete. Since it is broken wire, the wire is still attached. Desoldering braid. The variable resistor attached to the paddle changes resistance when the shaft is turned. To measure the maximum, measure resistance from end to end, maximum 4.7 kiloohms. The center moves so touch the end in the center. Now when I turn the shaft, the 4.7 maximum gradually goes down. It dropped to about 20 ohms. It is hard to tell from the numbers, but the resistance changes. It does work. But this does not show whether it is scratchy. If it is scratchy, the inside needs cleaning. Analog audio volume knobs. Use variable resistors like this. Restore it the same way as the working one. From the far side, black, yellow, red. The wire thickness differs from the cable side. Before pulling it out, leaving the insulation and twisting it with the insulation would twist it more cleanly, but I forgot because it has been a while. Lower the temperature. Pre-tin it. Bunsen does not do tack soldering, so I bend it, so it will not come off when pulled. Let's try adding heat shrink tubing. The tip is bent like a claw. Hook it and pinch it. Push in the heat shrink tubing. This will prevent shorts. 200C. Now compared with leaving it exposed, it should be less likely to break. Mass production cannot do something this troublesome. Inside the connector terminals, contact restorer. I cut it short so the cover can close. Pour it inside. It can remove dirt and help prevent rust. Wait a few minutes. Interdental brush. Blow out the liquid left inside. The contact resistance dropped a little. Put the locating pin into the hole. Put on the washer. Nut. Tighten it so it does not move. Now it will not move. But with only this it will loosen someday. Thread locker. Hardening it with UV resin is also okay. If you do not have thread locker, just apply a little. This makes it harder to loosen. The screws in helicopter and aircraft electronics are treated with thread locker. Magic medicine on the terminals. Wipe them clean. Graphite carbon 6B pencil. Prevent contact failure on the conductive rubber. There is an installation direction. Put the capacitor inside this frame. No rattling sound. Feels good. Really clean. Let's check operation. Switch on. Will it move? It moved. Good, cleared it. Nice. There was no scratchy contact failure either. Fully repaired. The cable also degrades. Slow down yellowing and deterioration. Silicone coating. Go on into the future.
Bye, Mission.